Welcome to Brainy Kids. Get ready to test your knowledge with fun and tricky questions. Let's get started with 3 simple rules. Interplanetary space is the vast region between the planets of a solar system, shaped by gravitational forces, solar wind, and cosmic radiation. Though often perceived as empty, it is filled with charged particles, micrometeoroids, and interplanetary dust that constantly interact with spacecraft and planetary bodies. Navigating interplanetary space requires precise orbital mechanics, gravity assists, and radiation shielding to protect astronauts from cosmic rays. Spacecraft traveling between planets must account for solar storms, fuel efficiency, and isolation, making long-duration missions incredibly complex. The Sun's influence extends across interplanetary space, guiding the orbits of planets and asteroids. As humanity prepares for deep space exploration, how will technology evolve to overcome these challenges? Could we one day establish permanent transportation routes between planets, making interplanetary travel routine? True or false? Spacecraft traveling between planets can use gravity assists to change their speed and trajectory. True. What is the primary force that governs the motion of planets and spacecraft in interplanetary space? Gravitational pull from the Sun. Fill in the blank. Interplanetary space is dominated by the gravitational influence of the blank. Sun. Fill in the blank. NASA's Voyager probes are currently traveling through the blank, beyond the last planet in our solar system. Kuiper Belt. Which of the following is a major challenge for astronauts traveling through interplanetary space? Cosmic radiation exposure. Fill in the blank. Spacecraft traveling between planets must account for the Sun's blank, which can damage electronics and affect navigation. Solar wind. True or false? Gravity still affects objects traveling through interplanetary space. True. Fill in the blank. The technique of slingshotting a spacecraft around a planet to gain speed is called a blink. Gravity assist. Why do spacecraft traveling between planets often use a gravity assist maneuver? To increase or decrease speed without using fuel. Fill in the blank. Interplanetary space is filled with small particles of dust called blank. Micrometeoroids. True or false? Interplanetary space is completely empty, with no particles or radiation. False. Interplanetary space contains solar winds, cosmic rays, micrometeoroids, and interplanetary dust that influence space travel. Fill in the blank. To protect against cosmic radiation, astronauts in interplanetary space would need to shield themselves using blank. Thick layers of water or lead. What kind of small debris is commonly found in interplanetary space? Micrometeoroids. Fill in the blank. The process by which a spacecraft adjusts its trajectory to maintain a stable orbit between planets is called blank. Orbital transfer. Fill in the blank. Interplanetary space is affected by bursts of high-energy particles from the Sun called blank. Solar storms. What are the biggest dangers of traveling through interplanetary space, and how can they be managed? The main dangers of interplanetary travel include radiation exposure, micrometeoroid impacts, and long-duration isolation for astronauts. To mitigate these risks, spacecraft can use radiation shielding, reinforced exteriors to protect against high-speed particles, and artificial gravity to reduce health problems from prolonged weightlessness. Advanced navigation systems and constant monitoring of solar activity help ensure safe space travel. or false? Interplanetary space is filled with high-energy cosmic radiation, which poses a serious risk to astronauts. True. What is one of the primary dangers for spacecraft traveling through interplanetary space? Micrometeoroid impacts. Fill in the blank. Spacecraft traveling through interplanetary space must account for the sun's blank, which can damage electronics and affect navigation. Solar wind. If a spacecraft traveling at 50,000 kilometers per hour needs to reach Mars, which is 225 million kilometers away, how long will the journey take? To calculate time, we use the formula. Time equals distance divided by speed. The spacecraft is traveling at 50,000 kilometers per hour, and the distance to Mars is 225 million kilometers. Dividing 225 million by 50,000 gives us 4,500 hours. Converting this into days, we divide by 24, resulting in 187.5 days. That means the journey to Mars would take approximately 6 months using this speed. Why do spacecraft traveling between planets use gravity assists? To conserve fuel and adjust their trajectory. If a probe travels at 30 kilometers per second for 10 days, how far will it travel in kilometers? To calculate distance, we use the formula. Distance equals speed multiplied by time. The probe travels at 30 kilometers per second, and we need to calculate how far it moves in 10 days. First, convert days into seconds. 10 days multiplied 86,400 seconds per day equal 864,000 seconds. Multiplying 30 kilometers/s by 864,000 seconds gives us 25,920,000 kilometers, or 25.92 million kilometers. This is the distance the probe would cover in 10 days. True or false? Interplanetary space contains no gravitational influence from the sun or planets. False. The sun's gravity dominates interplanetary space, keeping planets and asteroids in orbit. Fill in the blank. The boundary between interplanetary space and interstellar space is called the blank. Heliosphere. What force keeps planets in their orbits and controls movement in interplanetary space? The sun's gravitational pull. Fill in the blank. NASA's Voyager probes are currently traveling beyond the blank, having left the solar system. Heliosphere. True or false? Spacecraft traveling through interplanetary space experience weightlessness due to microgravity conditions. True. Fill in the blank. Interplanetary space contains small particles of rock and dust known as blank. Micrometeoroids. Which of the following is a major challenge for astronauts traveling through interplanetary space? Exposure to extreme cosmic radiation. A spacecraft takes 5 hours to travel 90,000 kilometers. What is its speed in kilometers per second? To calculate speed, we use the formula: speed equals distance divided by time. The spacecraft covers 90,000 kilometers in 5 hours. First, convert hours to seconds. 5 hours multiplied 3,600 seconds per hour equal 18,000 seconds. Now divide 90,000 kilometers by 18,000 seconds, which equals 5 kilometers per second. That means the spacecraft is traveling at a speed of 5 kilometers/s through interplanetary space. How did you do? Tell us in the comments below. And thanks for watching Brainy Kids. We hope you had fun learning today. Don't forget to like, subscribe, and hit the bell so you never miss a new quiz. See you next time, Brainy Friends.